Today we are going to solve systems of equations by graphing. There's two sets of directions. The first asks us to tell whether a point or an ordered pair is a solution of the system. And we're going to do the same thing we had done when we proved whether a point was on a line. We're going to substitute. We are going to take the x value, which is 3, and the y value, which is -1, and substitute those two numbers into the variables into both equations. So I'm going to take this -1, and it's going to go in for y right here. Take this 3, and that goes in for the x right here. And do the same thing with the other equation. So let me go ahead and rewrite my two equations, and then I'll do the substitution. And so I've got x minus 2y equals 5. And then I also have this 2x minus y equals 7. So just as before, as I had shown, I am going to substitute the numbers, so 3 in for x, and then I'll put this -1 in for y, and I'll see if it equals 5 at the end. So I go ahead and do some work there. I still have this 3, but I've got to multiply this first, and the two negatives make a positive. And sure enough, when I add the 3 and the 2, I do get that number of 5. And so that works. Now we can't say it's a solution of the system yet, because we have to make sure it works with both equations. And so I'll do the same sort of thing. I'm going to take the 3 and -1 and put them into these two variables. So here I have 2 multiplied by 3 minus -1. Notice that it's a minus y. Well, y is -1, so it's minus negative. And it should all equal 7 at the end. So I go ahead and do some work. Anytime you see a minus negative, you can always change that to plus positive. And then go ahead and multiply those two numbers together, and we'll come up close to the answer. Just got to do one more step after this. So 2 times 3 makes 6, plus 1, and we see if that equals 7. Sure enough, those two numbers do make the same value, 7 and 7. So what this means is this point is a solution of this equation and this equation. Now remember, I had said before, this big brace represents that this is a system. That means these two need to be graphed on the same coordinate plane. And what we're looking for is where these two lines cross. Since this point is a solution of both of these, that means these two lines are going to cross at that point of 3, -1. So we would say, yes, this is the solution because it works with both. If it only worked with one, we would just say no. Well, let's try this next one. We take the point and we substitute it into the two equations. So let's go ahead and rewrite our two equations. 2x plus y equals 5, and we have a -2x plus y equals 1. So we're going to do some substitution, see if it works, and makes 5 in one equation, makes 1 in the other. So we'll go ahead and rewrite what we've got. We've got 2, and it's being multiplied by that negative or that positive 1. So 1 went in for the x value. And then we have the plus y, but in place of y, we're going to rewrite that 3 this time. And then this should all equal 5 at the end. So you can see what I've substituted. I've taken the point and put it into the equation. So I go ahead and multiply, I get 2, add the 3, and sure enough, those two numbers agree. They're both the same. So it works with one, but we can't say yes yet as an answer. We have to do the next part here and see if that works. So I'm going to take -2, I'm multiplying it by the x value, and then I'm going to add the y, it should equal 1. Well, in place of the x, I'm going to write what x is. X is 1. So I put a 1 there. In place of the y, well, y is 3, so I put a 3 here, and then do the work. And so I see that then negative 2 times by 1, those make a negative 2. And I have to add 3, and since 3 is bigger than negative 2, so the answer is going to be positive. I have to subtract because they're opposite in sign. And I do get the same number, 1 equals 1. So yes, that point is where the two lines end up crossing. That is the solution of the system. Well, one more problem to look at, and this one has 2, negative 1 as the point. So let's see if it is the solution or not. Let's take the equations, rewrite them. X minus 2y equals 4, and 3x plus y equals 6. So we'll go ahead and do some substitution. Again, I'm putting the 2 in for x, the negative 1 in for y. So I'll leave some spaces here where those numbers go. Same thing on the other one. Leave some space, a space for x, space for y, and then I'll rewrite whatever's left over. So again, all I'm doing is rewriting the equation above, but in place of the x, I'm putting the value x is supposed to be 2. In place of the y, I'm going to put negative 1 here. Over on this one, in place of this x, I'm going to put 2. And then in place of this y, I'm going to put negative 1. And I'll see if those numbers agree. Well, we go ahead and do some work there. And here I have to multiply those two numbers first, and you notice that they're both the same sign. So that makes a positive. The two negatives there make a positive 2. And sure enough, those two numbers agree. So we're on the track to get 3 yeses in a row. Let's see if that works. So here I multiply. That makes 6, but the plus negative doesn't cancel out, so I just have a minus 1. And when I subtract those two numbers, I get two numbers that are not the same. So what that means is this point is a solution of this equation, but not this equation. So therefore, it's not a solution of the system. It has, in order for it to be a solution of the system, it means that two equations must share that same point. One line does, one line doesn't, so that one is a no. Well, let's take a look at the next type of problem. Here we have to solve an equation by graphing. And so when we solve by graphing, what we're going to end up doing is graphing those two lines and finding out where they end up crossing. So let's start with the first equation. We've got a negative 1 as the y-intercept. So what I'm going to do is I'm going to go down one space on that y-axis and put a dot. If we look at the slope is negative 2. Now treat that as a fraction. That means I'm going to end up going down 2, and I'm going to go right 1. Now I can only do this because y is by itself. So if y was not by itself, I couldn't use this method. I'd have to get y by itself first. So from this point, from this y-intercept, I'm going down 2, right 1, down 2, right 1. I can also go the other way. Remember, you could treat this as, this would be a positive 2 over negative 1. And that'd be the opposite of down and opposite of right. That'd be up 2, left 1. You can do that a few times, get some points on that line. And instead of drawing the line, we're going to leave them as points for now because we just want to see where these two lines are going to end up crossing. So let's take a look at the next one. Positive 5 is the y-intercept. That's where we're going to start. And so we go up 5 spaces. 1, 2, 3, 4, 5. Put a dot. Well here, what number can I put in front of x if I don't see a number? 1 is that number. And you can treat 1 as a fraction as 1 over 1. So that tells me to go up and to the right. Typically that's where I'd go. So I go up and then right 1, up 1, right 1. But that's not getting me to the line. So I need to do the opposite of both those things. I need to go down and to the left. So down to the left. Ooh, this next one's going to cross right here. Down to the left, that's where it crosses. You can see if I continue the line out, you can see where that would be. They'd end up crossing right at this point. Well, that's the solution. We just need to name the numbers. So here it's 2 spaces to the left, so it's negative 2. And here we are 1, 2, 3 spaces up. So 3 spaces up, so positive 3. So negative 2, positive 3. That is the solution of that system. There's another one. We've got the y-intercept of -1. So I'm going to go down one space on the y-axis, put a dot. Then use the slope. Remember the slope, 1/3, tells me to go up and then to the right. So I do that a few times. Up and right 3. Up 1, right 3. I could also go the other way. So it would be -1 over -3, which would be down to the left. Down to the left. That gets me on that line. Well, the next equation, we have a little different scenario. Here, we need to get y by itself. So what I'm going to do is, first thing I'm going to do is subtract that 2x to get y by itself so I can see what the equation is in slope-intercept form. So it's a +4, but it's a -2x. So that means I'm going to start at +4. So up 4 spaces. 1, 2, 3, 4. And then use the slope. Remember that slope is -2 over +1. So that tells me to go down to the right, down to the right, down to the right. And I just didn't get those lines to cross. So what I ended up doing is I ended up having a point which we're going to end up having to approximate this one. So the way I would do that is I would sketch in that line, since I didn't get the points to cross exactly on a line. It gives me an idea about where it might end up being. And so as I look at it, it looks like it's pretty close to 2 spaces to the right. So this is just an approximation. So I'm going to use a set of equal signs that are got a little bit of a curve to them to show that it's not exactly equal. So it's just an approximation. And it looks like it goes 2 spaces to the right, but it's down a little bit. Maybe down, maybe like 1/4 of a point. So it's just an approximation, but it's pretty close to this. So this is a good example of where this graphing method is limited. Well, let's take a look at the last one here. And we have another y-intercept of -1. So we'll start 1 space down on the y-axis. The dot right there, and then we'll use the slope. Well, here the slope is -2. So -2 over 1. So that means I'm going down 2 spaces and over 1. Down 2 over 1. Down 2 over 1. I could also go the other way. Up 2 spaces, 1 to the left. Up 2, 1 to the left. And I do that a bunch of times so I can see where these lines are going to cross. And hopefully they cross on a point rather than one that doesn't quite cross on a point. Well, I've got that same scenario I did last time, where I have to get y by itself. So what I'm going to do is subtract that x from both sides. And that way, I can see the equation in the slope-intercept form. So I've got y equals -x plus 3. Negative because I was subtracting x, +3 because there's no sign in front of the 3. So I'm going to go ahead and go up 3 spaces on that y-axis and put a point. And then from there use the slope. Now the slope is -1. So I'm going to go down 1, but then 1 to the right. So down to the right, down to the right, down to the right. And I don't see it crossing that way. I see it's getting further from the line. So let's go the other way. Let's go up and then to the left. So up to the left, up to the left, up to the left. Oh, there they go. They're going to cross right at that point there. So let's see what that point was. That point is over 4 spaces to the left. So that's -4. And I know it's an exact point, so I don't need to use those approximate signs. And then it's up. Well, that's 6. So this is 7. 7 spaces up. It's up right here at +7. So that's -4, 7. And that is the exact equation. So a system is where two lines, well, a solution of the system is where the two lines cross. Graphing is a good method, but you can see it works really well as long as it lines up on a point. But if it doesn't line up on a point, we have to approximate our answers. We can also always test whether a point is an actual solution by plugging in those numbers into the equation. So I could have done that with this one. Probably won't work out, but this is just an approximation about where it's at. With graphing, you can only approximate unless they come right up on a point, like A and C did. The next example will be using substitution to solve.